Hello guys, welcome back to my channel. This is part 58 of SQL Server. In this session, we will learn about transaction acid test. Before continuing with this session, I strongly recommend to watch part 57 of this video series. We know that a transaction is a group of database commands that are treated as a single unit. A successful transaction must pass the acid test. That is, a transaction must be atomic, consistent, isolated, and durable. Let's see what we mean by each of these. A transaction must be atomic, meaning all statements in the transactions either completed successfully or they were all rolled back. The task that the set of operations represents is either accomplished or not. But in any case, not left half done. Let's see what we mean by this with an example. I have two tables here, TBL product and TBL product sales. TBL product is like an inventory table which contains the information about the product and the quantity available. Now, whenever we sell a product, an entry should also be made into TBL product sales table. So when we sell a product, two things should happen. First, we should check the quantity available. Let's say, for example, I am selling 10 laptops. The first thing that I have to do here is to check, okay, what is the quantity available for laptops? 90. And then from that quantity available, I will have to detect the 10 laptops that I am selling. So we have to update this quantity available to 90 minus 10, 80. And then we also have to make an entry into this TBL product sales table. Product ID is 1. And the quantity I am selling is 10. Okay, so basically when we sell, a product, two things happening. Update TBL product, update TBL product, TBL product table, insert a row into product sales table. So that is what this transaction is doing. That is what this transaction is doing. Here, the first statement update TBL product table, and the next statement insert a row into TBL product sales table. And these two statements are wrapped inside a transaction. So the atomicity of a transaction states that both of these statements should be treated as one unit. Either both of them succeed. If one of them fails, the data that is modified by the other statement should be undone and rolled back, so that the database is in a state that is similar to before we have begun the transaction. So either both of them should succeed, or none of them. Okay, that is what is the atomicity of a transaction. The transaction should also be consistent, which means all data touched by the transaction is left in a logically consistent state. For example, if stock available numbers are decremented from TBL product table, then there has to be an associated entry in TBL product sales table. Then inventory can't just disappear. So for example, if I am selling 10 laptops, the first statement first update statement reduces that quantity from laptop quantity available. Here. And then let's say when we are about to execute the insert statement into TBL product sales table, the power has gone. Or something has happened. In that circumstances, a transaction should undo the first statement and put it back to 90. Otherwise, we can not account for those 10 laptops. So that is what consistency consistency says all data touched by the transaction is left in a logically consistent state. The transaction should also be isolated. The transaction should also be isolated. What do we mean by this? The transaction must affect data without interfering with other concurrent transaction or being interfered with by them. Okay. So if there are two transactions, transaction A and transaction B, transaction A should not interfere with transaction B, and similarly, transaction B should not interfere with transaction A. Both of them, should work as a single unit of work, and they should not interfere with each other. Okay. Let's see how transaction achieve isolation. I have this table TBL product, means go to the SQL Server Management Studio. I have this table TBL product. Now let's say, this is one of the transaction where I am updating this table TBL product. So one of the transaction where I am updating this table TBL product, set, let's say, quantity available is equal to 350. Where product ID is equal to 1. And now let's make this update statement part of the transaction. So begin transaction. So now when I execute this, look at this, a transaction is now being processed on TBL product table. We have not committed this transaction or rolled it back. So this transaction is still being processed. Now let's say there is another person. Now let's say there is another person, who connected to the SQL server, and he is also trying to update the same table. So update table, so he issue, let's say, another transaction. So let's say he issue another transaction, or let's just say he is trying to update the quantity now. Before updating, he wants to select the data and see. So he is issuing a select statement. So now when I say select star from TBL product, when I execute this, look at this, it says executing query. So let me execute this select statement. So it says executing query, but it will never get access to that table. Why? Because there is a transaction, because there is a transaction that is still being processed. It is not completed yet. That is why other users by default will not be able to see the data that is being that is being touched. By the other transaction. So here there is one transaction. Which is processing, a record from a record from this table. If you look at this, there are two records in this table. Currently, we are updating first record. Which means this transaction still being processed. We have not committed or rolled that back. This transaction still being processed. We have not committed or rolled that back. So now when I say select star from TBL product, so now when I say select star from TBL product, it says query, executing query. But it is still not showing. It is just waiting for that transaction to complete. On the other hand, let's cancel that. And when I say select star from TBL product, where product ID is equal to 2. I'm selecting a row where the product ID is equal to 2. Look at this. The moment I execute that, I immediately get that row. But then why? But then when I try to get the row with ID is equal to 1, that is being updated by other transaction in the other connection window. Look at this. It says executing. So if I go for product ID 1 and execute it, look at this. It says executing. query that is being updated by other transaction in the other connection window. So why am I not able to see that because that row is being logged by the database because another transaction is currently being processed. So this transaction is not interfering with this transaction here. So the transaction must be isolated. So how does the transaction achieve this isolation? Basically using locking mechanism. We will talk about transaction isolation level in the next session. Okay, so this isolation, this actually prevents this actually prevents transaction from making changes to data based on uncommitted information. For example, changes, to a record that are subsequently rolled back. Most databases use locking to maintain transaction isolation. Okay. So here I have not committed any data at this transaction. This transaction is still being processed. I have not committed any data at. That is why this user is not able to access that record. Now, if this user were able to access that record with product ID is equal to 1, then you might see uncommitted data. Because this transaction is still being processed. I did not commit the data. It did not make the change permanent to the database. So this user might see uncommitted data and he might make his decision based on that uncommitted data, which I I may later roll back. So in which case his decision might be wrong. So when I roll back that, he might see only the rollback data. That is why by default, if a transaction has logged a row, other users will not be able to see that. So a transaction should also be isolated, and a transaction should be durable. And this is pretty simple to understand. Once a change is made to a database, it is permanent. If system error or power failure occurs before a set of commands is complete, those commands are undone and the data is restored to its original state. Once the system begins running again, so let's say, for example, we are executing a long running transaction, and let's say half of the data is modified, and then all of the sudden there is a power failure. So when that happens, when the power comes back, the database should be in such a position it has to roll back and undo the changes that it has already done and leave the database in a consistent and durable state. That is what durable means. All right. That's it for today. Thank you for listening. Have a great day.